So I'm Vignesh. This is Vijay. We represent PalC Networks. Uh, so in PalC Networks, we are part of the open disaggregation. We build softwares in the open disaggregation network. So what we do is we build software and we work with hardware vendors and sell it as a bundled solution. One of the typical problem that we see is whenever there is a problem on the hardware, the only solution or only option that we have is just to send it back to the manufacturer so that they can do an RMA. And so this is a problem that takes more time, and we are not even identifying what is the actual problem. So what we thought is we can come up with a platform which can identify or predict even before the problem has happened. If we can predict the problem and provide a solution, it will be useful both for the manufacturers and also for the user to mitigate from the problem. So what we have built is a prototype, a platform which will monitor different types of hardware components. At least in this demo, we are concentrating more on the hard disk part. But this is a platform that we wanted to build for all the hardware components. And the other objective also what we had is to have a lightweight model so to infer the results. Yeah. So this is the idea what we have, and probably I'll hand it over to Vijay to give more info on the product. Yeah.
Yeah. Good evening, everyone. So take an example. Today's everything is working here, and some of the devices stops working immediately. What is the option we have? We don't have the options. In the software, you have the options. You can reboot the device. But if hardware fails, you don't have the option. You need to replace the hardwares. But if we have something which can tell in advance that, OK, this hardware may fail, so you have the options to carry additional redundant hardwares or at least plan in another way. So take an example of the data centers. The hard disks are the heart of the data centers. If hard disk fails, data losses happens. There are lots of financial losses, as well as organizational reputations goes down. So what we have developed here is basically a predictive maintenance solutions, where we have monitored around 1 million hard disk data sets. And we have trained our AI model so that it can predict the failures in advance. So in our solutions, there are two major things, basically. One is the data sets which we collect from multiple vendors, then we train, and then the platforms where our AI model can learn. So thanks to the OCP Foundations, who has provided us the platform where we have run this CI pipelines, where our model has been trained up. And once our model trained, then we deployed into certain our labs. Even we have a live demo here on our booth. There you can visit and you can see that, OK, it's really working. You can bring any hard disk and it can predict its states, basically. So how it works is basically like we have multiple data sources, and then we do the data ingestions and then pre-processing of the data, and then we train our model. The best part of our model is it's very lightweight. Even we can predict the failures on the edge device itself if it has enough processing powers. Take an example of the 5G radios. And there are multiple hopes around those 5G radios. If 5G radio itself fails, what we can do? We lose the connectivity. Now, if your model is optimally enough, it can predict there itself the failures, and it can just pass on the information to the admin. OK, there is a problem going to happen, so please plan to rectify that situation. So for the hard disk failure predictions, we have used smart attributes. There are around 256 attributes which are already available from various vendors. Some of them is relocated sector counts, reported uncorrectable errors, current pending sector counts, uncorrectable sector counts. These are some of the examples of the attributes which we have considered to predict these hard disk failures. So we have built a very basic user interface right now because of the time crunch. And in this interface, uh, we can extend it to like any hardware. Right now, our current POC is for the hard disks, but like we can extend it to a Wi-Fi module, or a power systems, or maybe a CPU, or maybe another, I would say, a robot, any hardware device, or maybe any hardware component in assembly line. So if, as long as we have the data sets to train our models, we can do. So for that, even we would like to invite the communities to come up with an standard APIs for the hardware stats, basically. If every vendor opens up, now is the era of the white box hardwares. Everyone is coming up with the open heart. You take my data, help us to identify that what problems can occur in my hardwares. Take an example of the electric vehicles. So now, like in next decades, the diesel vehicles will move away and only electric vehicles comes, the smart vehicles comes. If we have the data, we can predict in advance that, okay, your car may have some issues, so take care of like repairing it. Now, even the user will get the information which component will fail. We analyze the data and give the information in advance to the users. It helps our life making better and better. So we have scope to expand to like, it's like C. So we have started with an idea, and we would like to extend it to all aspects of the hardware failure predictions. Yeah, thank you.
You guys have any questions?
Thank you. Very good presentation. You mentioned about EV. So you just consider the whole EV as one piece of hardware, or you just look into the resources within EV and remote manage it?
Exactly. So there are two aspects, because EV is a very big system itself. So we are specific to the each components, basically within the EVs, which component may fail. So we give, like, take an example in one of the slides. Hard disk is one of the component, but in the system there are hard disks, there are network line cards, there are Wi-Fi modules, there are other sub-assemblies. So we consider like an entity which can gives us the information regarding its lifespan, regarding its decaying over the period of the times.
Yeah, thank you very much.
Thank you.
So if you wanted to scale this, right, and you had like 10 trillion devices, how would you scale it?
Yes, that is a challenge. However, we right now, like, we have used the MongoDBs basically to store and process more and more data, but we definitely need the GPU powers only for the training part. Once our model is trained, then we utilize very minimal powers. Only thing is how we make sure that, okay, the communication channels keeps running for all those million devices. So we periodically update those trained models on those devices. So we do not hog the CPUs that, okay, every milliseconds you pull the data. No. Our model is trained and it put into that particular nearby edge. So that can take care of the prediction of failure of those devices. That's how we can scale.
So you have a cloud for your training. You're training your models in the cloud, right?
Yeah.
How often do you train the models and push them down to the edge?
Yes. So right now, like, we have trained, like, okay, every 24 hours, but that frequency can increase or can decrease depending upon, like, the new hardwares. So right now, like, we trained our model on, like, last 6 years hard drives datas. That was huge data. Now we start with the new hardware, then, like, okay, initially learning period is more. Then later on, like, the training of the model may not be that frequent, as long as you are not getting some different data sets.
Thank you.
Thank you. Thank you very
All
much.
right, team 3, thank you very much.
Thank you.